Okay, now we head back to the PowerPoint for some more concepts, and then we'll come back to R. Asymmetric misclassification cost. We already talked about this, I think, previously. So misclassification types, okay, there are two kinds of misclassifications that we could do. It can be false positive. We classify as positive, but it's actually not positive. Okay. We classify as negative, but it's actually positive. Okay. Now, you can think of many, many instances where these two errors, false positive and false negative, they are not of equal importance. Right? Now, like, look at it from medical point of view. So you're doing a diagnosis. Now, false positive, okay, while bad, okay, false negative is much worse. Because the person could have gotten treatment, we are overlooking that. So that's much worse than false positive, right? And same with fraud detection is another example. Where false positive is bad enough. Okay, I'm not saying that's good. False positive is bad enough, but false negative is worse. Okay, so that's the reason why we need to look at. Okay, if you look at the regular misclassification rate or accuracy rate, it's treating both errors equally. It's not differentiating between the two errors. So we have to weight these errors differently. So that's why we have the cost-benefit analysis. Okay, and again, benefits are not the same either. You know, if you look at it from the positive side, you know, from a marketing point of view, if you classify a potentially successful client as not potential, okay, is not a good customer, then you lose the opportunity. So here, false negative is more costly. Okay, so it depends upon situation. Which one was more important? Which one is less important? Okay, suppose here is an example, promotional offer. So there are actual 0 from previous offers. Okay, 0 meaning so not accepted, only 10 people accepted. So this is the ratio. 1% of the people who were given an opportunity accepted the offer. And so that means if you say, all right, so it's only 10 people, so we predict everybody to be 0. Okay. Then our error rate is 1%. And instead, if you have a modeling method that does this, okay, not all are classified as 0, okay, but some are classified as 1. So there are 28 of them are predicted as 1. So now we have an error rate of 2.2%. It's definitely more than this. Okay, that's because we are considering both errors equally. But if we associate different costs to it, okay, so profit from a 1 is $10, cost of sending orders is $1. Okay, so that means here, if you predict 0, okay, so we are not sending anything here. Okay, we're predicting 1. Okay, we're going to be making $10. I think I made a mistake here. How many are predicted? Oh, okay. So that's the dollar amount. Okay, so the net profit is 0 here, whereas here your predicted 0, there is nothing. And predicted 1, if it is 0, the cost is just sending out the mailer. So that's minus 20. And from the 8, you're going to make $10, so your profit is $60, and obviously this one is better. Okay, so that's the kind of, and you can also do this on an opportunity cost basis. It's the same thing. Okay, so let's look at how to do that in R. Okay, asymmetric misclassification cost. That's what this is. Now we need another library for that, and that is customer scoring metrics. Okay. Customer scoring metrics, and then we run that library. All right. Okay, so there are two ways in which we can specify the cost. All right. So we now have the actual class and we have the probability, right? All right. So misclass cost is the function. Now this one wants the probability first and then the actual class, okay, because different people create these different libraries and they have their own peculiarities. So, all right, so we need the probability here and then the actual class. Okay, so those are the two basic information, and then we have cost type. Okay, there are 2 or 3 different ways in which you can specify. We're going to look at 2. Okay, so one is the matrix cost. So it's something like this. Okay, so here, so if you actual and predicted, okay, so if actual 0, predicted 0, there is no cost. Okay, but actual is 1, you predicted 0, there is a cost of $10. Okay, now if you predicted 1, there is cost of $1. Oh, okay, so 0, 10, 1. Okay, so we then say this is cost type is cost matrix. Okay, and then we say costs equal to, and we specify the matrix now. So we have to specify a matrix, so we use the R bind. Okay, so you give them as vectors. Okay, the first line is 0, 10. And the second one is 1, 1, right? And then if you want to use a different cutoff point, you can do that. You can use 0.5 as cutoff point, or you can use something else. So if you want cutoff equal to say 0.4 or something. Okay, so it gives you the misclassification cost for the cutoff point of 0.4. Okay. Now you can capture this again, you can save it into a list, and then you can access the cost, same way like before. Now let's look at the other one. The second way of specifying cost is cost ratio. So this is because very often it's very difficult to figure out what the exact cost is going to be for the 2 different misclassifications, false positive and false negative. But it will be easier to look at it as a ratio. So false positive is twice as bad as false negative, or 10 times as bad as negative. Okay, so you're now not looking at the actual cost, but only the ratio. So that's what this is. So then you can specify the cost now is not a matrix like we have here. Okay, instead it is just the ratio. So you say the cost equal to 3, so that it's going to use 3, 1 and 3, okay, 3 times the cost for false positive, and it will give you the cost in this way. Okay, so this is our asymmetric misclassification costs.